My mother had a pharmacy at home, and as a child I always dreamt of bringing one of those new drugs to the pharmacy. So that seemed to me like the most incredible thing to do and the most ambitious thing to do. And so after my studies as a pharmacist, I went into research and then really focused on the aspects where scientists need to design, make, test and select that final molecule that is that drug that makes the difference in patients. And it takes a combination of skills to be good at it, but I've done it for over 30 years. I've found it fascinating to be able every day come in the lab and dream that is going to be that next drug that's going to end up in the pharmacy. I've worked with Fibrocor for many years, as I was leading a research team of about 100 scientists working on fibrosis, and part of that program was together with Fibrocor. And going forward 10 years at the end, in fact, of the whole research program, the best data we got with the Fibrocor targets.
Fibrocor was founded in 2017, and the basis of Fibrocor is a human patient data bank that has patient data that's been available and collected over the last 20 years. Because we're in Canada and there's a single payer system, we're able to track those patients over time and how the disease has progressed and how they've responded. And so one of the biggest challenges in fibrosis has been a lack of translational targets. They either haven't been effective or they've had toxic side effects. So we've taken a novel approach at Fibrocor. All of the targets that we're focused on are involved in the later stages of fibrosis, not in the inflammatory stages, but in the propagation stage of the disease. And that's what we think is going to differentiate us from all the other folks working in the fibrosis space.
With idiopathic pulmonary fibrosis, patients develop progressive scarring of their lungs, which ultimately causes the lungs to stop working. And so these patients develop respiratory failure, which is ultimately, unfortunately, what kills them. The first symptoms are very mild, so these tend to occur in older people who will put breathlessness down to being unfit or getting older, so they'll often ignore their symptoms for many months. And then when they do go and see a doctor, the symptoms are often put down to other diseases like emphysema or heart disease, and so the average delay between first symptoms and diagnosis is about 18 months. Which unfortunately then delays our ability to start treatment. Challenge 2 is that these patients get worse with time and unfortunately develop severe respiratory failure requiring oxygen, sometimes lung transplants, end-of-life care. And although we have treatment, we are just slowing down the condition, we're not reversing it. So when we see someone for the first time, we know that they are going to inevitably progress, albeit we hope that with treatment at a slower rate than they would have done otherwise.
What's very novel about Fibrocor is they've biobanked human tissue samples and annotated through gene transcripts those druggable targets which are important in fibrosis, and have then developed lead molecules in different disease areas specifically targeted on the back of patient data, and that's quite unusual. Because it's often difficult to get hold of human tissue and annotate the targets like that. Bill Newsome has built a fantastic team of real experts in, both in drug hunting and in the development in IPF and renal disease. So Piet Wigerinck was the CSO at Galapagos, where I met him when I was working on the fibrosis programs there. And amongst other people that he's brought in, we have real expertise in the diseases that, really count in terms of fibrosis. So idiopathic pulmonary fibrosis and renal disease, which is what we're concentrating on. My area of expertise is IPF, and I've worked in that space for over 15 years.
The lung isn't the only organ that suffers from fibrosis. We recognise that fibrosis can affect pretty much any organ in the body, whether that's the bone marrow, the liver, the kidneys, the heart. And there are certain genetic conditions where we actually can see individuals who have fibrosis in multiple organs. But often patients will have one single organ affected, and in the same way that fibrosis of the lung can cause respiratory failure, fibrosis of the liver will cause liver failure, fibrosis of the kidney will cause kidney failure. And so for people living with these fibrotic problems, it has a massive impact on their life and it shortens their life expectancy. If we look at all fibrotic diseases, not just of the lung, we still need to better understand how the conditions occur. We need to better identify risk factors so that ideally we can screen people before they develop disease. In the ideal world, we would be starting treatment before the organ has become damaged so that we can prevent the long-term consequences of fibrosis. We need fresh ideas, we need fresh impetus, and I think that's where Fibrocor come in. They have novel approaches to treating fibrosis, and I think it really provides an exciting opportunity for us to try and shift the dial in terms of how we treat fibrotic diseases, not just of a single organ, but of many different organs in the body.
What we're trying to do is understand that disease progression and stop it and try to reverse it. And that takes novel approaches, and it really takes human translational data, as well as using all of the best preclinical models that are out there to predict success and safe outcomes for patients.